This is geometry 10.5, volume of cones. Volume of cones are the same concept as the volume of a pyramid. It's 1/3 the base times the height. Except with a cone, the base is always a circle. So in our case now, since we're working with cone, B is the area of a circle. When we're working with a pyramid, the B would be whatever the base was. Often it's a square, it could be a rectangle, it could be a triangle, but in our case here, the base is always a circle for a cone. We still have a height, and because we're talking about a circle, we now have a radius. Now zooming in close, this tells us different parts about our cone. There is a slant height. We don't typically want the slant height for volume. We want to know the actual height, right down the center, from the vertex down to the center of the base. So we come to our first example here, and we have the radius is 10 and the height is 16. So our volume is going to be 1/3 the base, which is pi r squared times h. So 1/3 times pi 10 squared times 16. And we can go to our calculator. One-third times pi times 10 squared, because that's pi r squared, times our height. 16, 75, 52, because the third number is 5 or bigger. And those would be meters cubed, cubic meters. Questions about that? Then we have volume. Again, is 1/3 pi r squared times the height. Here they give us the radius again. Oh, look what they gave us here. They gave us the slant height. We don't want the slant height. We want the actual height. So we have to be careful about that. That's our radius. And they're not giving us the actual height. They're giving us a slant height. So we need to calculate using Pythagorean theorem. Hypotenuse squared equals leg squared plus leg squared. So that's 81 equals 16 plus h squared. We minus our 16, we get 65. So our height, after we take the square root of both sides, is the square root of 65. Now we're ready to do our calculations. The volume equals 1/3 pi. R is 4, so we square that, times our height, which is the square root of 65. Don't put in a decimal. Keep it the square root of 65 because that's your exact value. It's not a rounded value trying to get to an answer. Then we can use this exact answer, 1/3 times pi times 16, because that's 4 squared, times the square root of 65. We're just going to use the square root of 65 in our problem. and that gives us a volume of 135.08, and these are feet cubed. Questions about that? Look at this next one. What's different about this one? We notice that they give us a degree value of this triangle. They tell us the height. They give us this acute angle. But what they're not telling us here is what the radius is. So what method are we going to use to find the radius? We're going to use SOHCAHTOA. So SOHCAHTOA tells us from the 70s point of view, the 25 is the opposite side. The R is the adjacent side. We're not looking for the hypotenuse, so we're working with the opposite. We're trying to find the adjacent, so we want opposite and adjacent. The only one that has opposite and adjacent is tangent. So we're going to do tangent of 70 equals the opposite side over the adjacent side. So this is how you solve a trigonometric equation. So you put this over 1, cross multiply, but this is where people still make mistakes. They still say that they're taking the 25 and timesing the tangent of 70. But that's not what the 25 is timesing. The 25 is timesing the 1. The R is timesing the tangent of 70. So this should be R times tangent of 70 equals 25 times 1. Now I want to divide by the tangent of 70. And that gives me R equals, you need to be sure you're in degree mode. You need to be sure your degree is highlighted. A good way to test that is to try the sine of 30, and you should get 0.5. So if you're getting 0.5, that means you're in the correct mode. 25 divided by the tangent of 70 gives us 9.01, because the third number is going to round up, and it's going to make this 9 round up, and it's going to make that a 1. 10 if you want to say that. 9.10. So now we're ready to find the volume. 1/3 pi 9.10 squared times the height. Since we're using a calculator and I've shown my steps, I can type this into the calculator. Parenthesis 1 divided by 3 times pi times 9.10 squared times 25. And I get 2,167.97. These are centimeters, and it's volume, so it's cubic centimeters. So there's all these teeny boxes that would make up this cylinder. 2,167 of them. Questions? All right, we come down to our next one. Notice that this says the volume of a right cone. Well, a right cone implies that the vertex of the cone is right over the center. So there's no surprise. Alright, this is a typical cone. The volume of this cone is 1350 pi. You got to remember this pi symbol. Watch for the pi symbol. 1350 pi. And they're telling us the radius, the distance to the outside, is 18. So we can find the height of the cone, the h, by taking our formula, 1/3 pi r squared times h. That's what we have. We're going to plug in our value for the volume, 1350 pi, 1/3 pi times 18 squared times h. We're supposed to find the value of h. So, a couple different things you can do. I'll get rid of my pi's first. I divide by pi, and that's the advantage of having pi on this side. We don't get a decimal. We just get 1350 times 1/3. 324, because that's 18 times 18, times h. Now there's a couple different things we can do. 1/3, because 3 plus 2 plus 4, that adds up to 9. 3 goes into 9, so I know 3 goes into 324. It's a neat little trick. 3 goes into 3 once, 3 goes into 24 8 times, so 3 goes into 324 108 times. Now I'm going to divide by 108. That gives us our h. So 12.5, and our units are meters. That is the height of our cone if it's going to have a volume of 350 pi. Any questions with that? You see where that's coming from? Next, we're going to be talking about an oblique. And they call it a solid, which is just three-dimensional. This is a cone, but it's oblique because the vertex is not over the center. It's off to the side. It's off to the side so much that we are up exactly 90 degrees, which is just fine. That's all we need to know. We still use the same formula. And the side of our oblique cone is going to be the actual height because it's straight up. So our volume is 1/3 pi 1.1 squared times 2.7. We can type that into our calculator. So we get our 1/3 times pi times 1.1 squared times 2.7. That gives us 3.42. And this is volume, so it's going to be cubic. So we have centimeters cubed. Cubic centimeters. Last one. Bit of a story problem. We're making coffee using a cone-shaped filter. Have you ever seen a cone as a filter inside of a coffee maker? it takes 14 minutes to brew an amount of coffee that'll be equal in volume to the filter. Find the flow rate of the coffee, this coffee filter, in cubic inches per minute. So we want to find the cubic inches, we want to find the volume, then we're going to divide it by the number of minutes per minute. How many minutes takes 14 to go into all of those cubics? So the volume equals 1/3 pi r squared times h. Notice I write the formula every time. So 1/3, the radius is 3, and the height is 3.5. One-third times pi times 3 squared times 3.5. That gets us 32. Third numbers, 5 are bigger, so it makes the second number 1 larger. 32.99. Those are inches cubed, or cubic inches. So we're going to take the 32.99 and divide that by 14. And we get 2.36. And this would be cubic inches per minute. That's the flow rate that is coming through this cone.